Okay, so now we're gonna follow up with our next speaker. One second. Professor Robin Murphy. Welcome, Professor Murphy. Hello. So Professor Murphy is, okay, we heard a bit of echo. Okay, I'll still try. So Professor Murphy is an American computer scientist and a roboticist. She is the Raytheon Professor of Computer Science and Engineering, at the Texas A&M University. And she is known as a co-founder of the fields of rescue robotics and human-robot interaction. She is the founder of the Roboticists Without Borders, and for her contribution to rescue robotics and insertion of robots into major disasters, she received multiple recognitions. Her primary research is in AI for mobile robots as applied to disaster robotics, and she focuses on human-robot interaction. And with her team, she has participated in 27 disasters or incidents and over 35 exercises of gathering data spanning urban search and rescue, structural inspection, hurricanes, flooding, mudslides, mine disasters, radiological events, and wilderness search and rescue. Professor Murphy, thank you for being here and thank you for being supportive of all of this event, and the floor is yours.
Well, thank you for having me here. And thank you all for coming. I'm going to be talking about drones and AI for disasters. Okay, I'm going to try to, let's see. There we go. And I work with drones and all types of robots, but drones in particular since 2005. And you see this drone footage from Morocco, and it really highlights, thank you so much for being here. Thank you for caring. Thank you for putting your talents for this. So let me share with you a little bit about my experience. As we've said, I been in, actually it's up to 30 disasters in 5 countries. But so we're talking about drones, let's talk about what drones can do. Here's the Miami Beach collapsed building, and that's just one building. Imagine an earthquake like Morocco with multiple buildings, multiple cities impacted. Drones can immediately provide that tactical situation awareness, but look at what we've been able to do with structure from motion and all of these advances in photogrammetrics, flying daily to not only get sort of a 3D representation and document what's going on, but now you're starting to overlay and work with the GIS, the graphical information, the geospatial information, being able to use it to tag and document every aspect. In this case, get the volume of debris that's being moved, which we'll talk a little bit about later. So that's about a little bit about drones, a little bit about disasters, but what about AI in general for disasters? We've heard so far some aspects of it. So I'm gonna give you a little bit of a bigger view. All right, so one of the things I'd like you to walk away with this as you think about your projects and how to best apply them is that the phase of the disaster influences the role of AI, and it also influences the end user who's going to be using that AI. So let's think of emergency management as a straight line. You can think of it as a circle as well, a cycle where you have those things that happen before an event, the prevention preparedness, then you have the event, then you have the response, then you have the recovery, which should lead in preparedness prevention for the next one. So the government agencies, local, state, federal, are generally involved with the planning, inspection, the prevention preparedness phase. And you saw in Libya just a disaster because there had been no inspection of the 2 dams that failed. So that's part of what government does. During the response, usually that's about 72 hours, 3 days to a week. That's when everybody's evacuated, you're focused on public good, trying to save the most lives possible, trying to make sure the infrastructure is safe, there's not going to be a secondary collapse, trying to make sure there's no hazardous materials or pollution going, those types of things. And so you're seeing with formal responders. Then after that, we shift into the recovery phase. People come back to their homes. They bring in the insurance, starts looking at stuff. You start rebuilding. The government, local governments have to deal with all that waste and debris. They have to open up services. A big one is to get your government open so you can start getting building permits, things like that. And then we see what we call humanitarian relief begin to emerge as being very important. So the first 3 days, you're just trying to keep everybody alive and mitigate. And now you're worried about individuals. Now you're taking care of them individually. So that's a bit of an overview. So let's get some ideas. I'd like to share with you some ideas from our emergency management partners. And the point is in no way to say that what you're working on, your ideas aren't good. Your ideas are great. I'm sure they are. These are just some for those of you who don't have ideas, or there may be things along the way that will inform and inspire aspects of your ideas for today. All right, so first off, let's look at this. You've got a building collapse. One of the first questions is where is the possibility of survivors? So here at Surfside, figuring out where the apartments collapse to. And a lot of things you use, not necessarily visual information, you're using reasoning about, well, okay, it was 1:30 in the morning when it collapsed. It was in high season, resort season. So the condominiums were full of families, and they were probably, since it's family oriented, probably at 1:30 in the morning, not doing a wild party. They were probably asleep in the bedrooms. So where did the bedrooms fall? Where are they? Can we locate those and see if anybody's there? And that also gets in this idea of predictions versus reality. So in the United States, we use the HAZUS earthquake models, and that can predict damage, but they also give you a little bit of uncertainty. Well, the question is how, when you've got something that is, a huge multi-province area, how do you resolve the uncertainty? I mean, that could be hundreds, thousands of people that you need to check on that weren't tagged by that. So you want to check that. So do you do it with social media? Do you mine and see what they're saying? One of our researchers here at Texas A&M, James Caverly, discovered that social media, the pictures of the disaster for about the first 4 hours after disaster turn out to be pretty useful for civil engineers to determine damage. After that, then we start photoshopping sharks in and take pictures of the kids and stuff like that. All right. Also, how do you exploit the use of drones? You got to get them out there somewhere. Fly over, can see things. What about your security cameras, your traffic cameras? How can you tie into that? Which leads to this idea of reasoning, data mining, and computer vision machine learning. And a big question we have, and this is video from Hurricane Michael. Okay, great, but can the responders get there? Tying into Jacques' previous talk. Are the roads passable? If they are, can they be reopened? Here you can see coming up, you're seeing an entire bridge is out, which meant that you couldn't get into that part of the disaster except by going north and then coming back west to get to that. This was in Florida. So sheltering delivery. One of the big things we always get people say, oh, we've computed the optimal location for a shelter, or we've computed the optimal location for delivery of medicine and supplies, which is great. The question then becomes, can the civilians actually get there? Where are they already congregating? A lot of times they'll go to either a Walmart or to a hospital. And the question becomes, can they get off to a drop-off point? And how would they know that that perfect optimal drop-off point is there and exists? And so that brings a lot into both computer vision, machine learning. We've got spatial reasoning, but we also have a lot of behavioral reasoning and behavioral communication to think about. And the responders themselves are getting overwhelmed with data. I mean, so we've got a lot of data, a lot of visual stuff. So our research with drones since 2005 have shown that there's really, the drone flights are on the order of 12 to 15 minutes, unless you're flying a mapping mission, which is kind of a different thing. But about only 90 seconds of it is really useful to the civil engineer, the emergency planner, the whatever. Well, what do you do with that? You don't want to send a 15-minute video by email when there's almost no internet up. And so it becomes which 90 seconds? And then how do you annotate and snippet it without expensive video editing software? It's kind of like, how do you, like getting a ring, it's just so simple, just short buffers, and then you pick that and you send it and it just takes care of it for you. And then a big issue is how to prioritize. Some stuff I see in the field may not, it can wait a couple of hours to get through, whereas one of their things is like needs to go right now. So there's some fundamental work in human machine interaction I think that can be done. One of my favorite super hard problems is predicting and detecting and calculating the volume of debris and type. So after you've had a disaster, everybody's back to their house, they're tearing out stuff. They got to get rid of all of the rotting carpets and curtains and clothes and bedspreads and all that. And they have other things. And you normally in the United States and in most countries, you'll need the waste removal is divided into categories, like your trees get a special vegetation because that decays differently and can be composted. Then you've got building materials, your cinder blocks, your bricks, your roof. Then you have the textiles. Then you have things, electronics like your washing machine. Those things all have to go into different categories, which sometimes happens, not always. You can kind of see people didn't quite get the sorting there in Hurricane Harvey. They never do. So people have to come and estimate not only the volume, but they have to say, well, how much is a certain pile? Because that influences the amount the city or county has to pay to clean it up. And it also tells how many dump trucks and what kind and where are you going to dump it. So there's a lot of downstream consequences. So let me just wrap up with some challenges that I see for us as computer scientists is that, first off, a lot of this has to do with computer vision machine learning, but the data sets just really aren't very good. We've got the FloodNet and RescueNet developed by Miriam Renifor up at Lehigh. She used some of our work. Yay, thank you. It's good for a wide area, but it's taken from hurricanes, not earthquakes. It's really hard to simulate images, particularly things like ones with people in them. I mean, the synthetic imagery doesn't kind of work because people forget that survivors are going to be covered in dust. They may be covered with rubble. I mean, so they're not a full thing. They may have their arms and legs in very different positions than if you use your standard gaming skeletonization algorithms. And also, using satellite images are good, but a lot of times we in the field don't get that for the first 72 hours. And if there's a cloud cover or something, they can't see. Satellites aren't pointing absolutely everywhere all the time. And they have very different resolution angles than the drones. So drones, these low flying and expensive ones that the Moroccan military were using immediately are very useful, but they're different. Okay, the data may be available. Like I said, you've got things like your social media, you've got the drone data sets, probably not going to be in a single place. And then we get into some data may be available that you can scrape, but you've got to really think about the privacy and unanticipated ethical consequences. For example, a big thing in logistics and planning is special needs community. If you've got people who are ill, elderly, you've got to move them somewhere. You also have people who are disabled. You typically put them and give them different facilities because they need a lot more medical support. Well, where's that database that says where do they live? Well, it turns out getting that's very hard because that level of privacy, these communities are very vulnerable to stalkers and criminals. They don't want that out there. So you have to be aware of that. Another thing we saw in a massive missing person search, one group was saying, hey, we've got computer vision pictures. We're posting to the Facebook. Please let us know. Everybody go look and see if you can find dead bodies in this and let us know where they are. And it's like, wait. That's not really thinking through the privacy, the dignity, the impact of just posting pictures that could have your loved ones there on Facebook for people to, it has to be controlled, a little bit more sensitive. It's easy enough to do. And now that you're aware of it, I'm sure you'll take care of it. So to wrap up, things to think about is AI is absolutely for disasters about getting the right information to the right person at the right time so that these emergency managers can make the right decisions. And do remember that does include secondary consequences or constraint satisfaction aspects. The first 72 hours is the most critical for life-saving and mitigation after the event, but please don't ignore the value of preparedness, prevention, and recovery. And finally, government agencies, NGOs, civilian, we all have a role to play in disaster management. So anything you can help any of these stakeholders is great. But the main thing is AI has become so good. We've got this foundation for making a transformative difference. So thank you for being here because it's you who'll make that difference actually happen.
Thank you so much, Professor Murphy, for this amazing talk. So do we have questions in the audience? Okay, if not, I have a... Oh, okay, go ahead.
Hi. Thank you, Doctor. It was really, really amazing. And yes, it was. There is many solutions that you propose here, and it was very interesting. And what we are facing now in Morocco and also in Libya is a challenge. It's an artificial intelligence challenge, but it's more a logistic and an optimization challenge.
Yeah.
And I think that we didn't have enough data to apply directly, our all, beautiful algorithms that we are proud of. But I think that if there is some more collaboration between the two community, between operational research community and also artificial intelligence, and we are lucky here in Montreal, we have three big research center in optimization and also in artificial intelligence. There is many collaboration, but I think that it's not enough. And we didn't have too much in this area of research. So how, for example, for all the people participating here in this hackathon, how we can collaborate between the two community, how we can have more innovative solution based in data, but also by using and all that we developed before in operation research in this face to those problems. Thank you.
Thank you. And let me just add to that. It's just absolutely with the collaboration. So here's what gets very exciting. I'm part of the AI Institute for Societal Decision Making. And how do you take the fact that we're flying drones? We can tell you if, with good computer vision machine learning, we can tell you if the roads are open or not. I mean, that's a project there. And then feeding that to the person who's doing the logistics and trying to come up with a resource allocation. How do we tie all this together? Well, the first step is knowing that the other stakeholders exist and to talk with them, which is what Joshua had talked about. And we're standing by to help and make those connections and help in any way we can.
Thank you. And we have another question online. So how can we help Morocco with the rapid implementation, knowing how spread the villages are and the nature of the terrain?
Sadly, there may be of some of the great ideas in computer vision, machine learning, and things like that. It may be too late. We're in the recovery phase now, right? And so what we find is that first 72 hours is not only super important for life-saving and mitigation, but while everybody's off doing the life-saving, meanwhile, this group is at the same time trying to plan ahead. The emergency managers are trying to get the waste removal, trying to figure out how much shelter to bring people, how long are they going to need alternative housing, how much food does that make, what kind of money does that we need to ask the UN for, those types of things go in. And so all of that should already be in the works. And once it gets going, it gets hard to add. The most important thing is that we know there's going to be another earthquake. We know there's going to be another disaster soon. And so taking and seeing what we can learn from here, not only to help now, but to make sure we can do better for the next one.
Yeah, that makes sense. It's very hard to imagine AI solutions to be implemented in the first 72 hours unless we plan ahead.
And that gets into another aspect of trust. The emergency responders, so let's think, these are people with public accountability. They can't do anything wild and crazy that might hurt anybody. So they tend to be very conservative on adoption of new technology. Now, here they are in the middle of a disaster. They've got everything happening. Their own family has probably been impacted. There's dealing with it is so emotional. It's hard no matter how logical and scientific you are. There is just something about a disaster. The emotional toll is there. So you haven't slept. Typically a responder, the first 52 hours will get maybe 3 hours of continuous sleep. So you're taking cat nap. This is not a great time to say, hey, we need you to download this new program and we need you to learn this new interface. And okay, the download's taking forever because the wireless is very limited. And we need you to do this. And it's different. We use a different convention than your favorite apps on your phone. Okay. So it just doesn't work. they just look at it and it's like classic human-computer interaction. It's either push a button and 5 minutes later you understand how it works and it's giving you valuable information, or it's just too much to try to adapt to in the middle of the disaster.
Yeah, I agree with you on that. I have one last question, but unless I don't know if there is other questions from the audience. Okay, so I had one last question on your point of the challenges for the data sets. So, for example, in Morocco, the legislation is a bit complicated, so you can't really deploy drones the way that you want to. What is your opinion on that? Like, how can we, with like little data, try to get the most impactful solutions in our case?
Well, I think in every country has has aviation regulations. You just don't go out and fly drones. And drones have been typically flown. All the disasters I showed wasn't me as a university professor flying. It was me working for one of the formal agencies having jurisdiction and coordinating with the crewed aircraft flying over here and then the helicopters doing the lifting and all that. So there. I think the bigger challenge is there's probably a lot of groups that have been flying, a lot of agencies in Morocco that have been flying drones and have the data somewhere. It's getting to them and getting them to release it. I mean, it's not like they're trying to hide it, just no one ever thinks to say, oh, this would be great for the computer vision machine learning people. So I think that's one of the things where international cooperation, UN and CIROC, those groups can help get that information so that we can use them and create, sanitize them to make sure there is nothing private information, anything uncool, but then release it for us to work on.
Okay. I have another question, if it's okay. One last question. So a lot of people in Morocco in the very remote villages, they don't have access to like telecommunications to communicate. And I was wondering, what is your opinion on that? How can we tackle this?
So it turns out in almost every disaster, you have lost your communication grid effectively for 72 hours, maybe longer. And in some parts, I live in Texas. Texas is big and part of it is desert and there is no connectivity. In other places, there's a lot of mountains and they lose connectivity there as well. So it's a constant problem. And if you're doing solutions in the cloud, you have to be very careful to make a distinction between what's being done in the field and what's being done back at the base of operations, the nice room with the screens and the politicians are, that will typically have that. And kudos to Amazon, AWS, is that they've tried to create a system that they can port out there and try to take and do a lot of the edge computing for us in the field. But yes, and that's one of the sad things to me about disasters. On a wide area disaster like a hurricane, an earthquake, typically if you're in the rural areas, you're very vulnerable, but nobody can get to you. It's easier to get to people who live closely together in urban areas. So.
Okay, we have another question from Professor Lubna. You can maybe come here.
So just another question. It's about optimization, how we can use, for example, what you have done in machine learning, typically in the optimization. I'm speaking about how we can combine between optimization and machine learning. For example, in some classic, problems, we are using clustering before doing, to decompose the problem and to facilitate, to reduce the complexity of the problem. We can do that. And also to accelerate the process of finding, the most, interesting solution, how we can do that in this area of research, typically in some problem that you find to supply in the relief phase when we have some natural disaster. Thank you.
Sure. So one of the problems here is that I'm not an expert in optimization. I actually specialize in the human factor side of using drones and autonomy. So I may be the last person on the earth who wants to answer that question. But I think it leads into the idea that there's wonderful optimization, perfect optimization, which is really hard to get to and often very compute intensive. Then there's sort of just-in-time algorithms that's pretty darn good, and close enough, and I can get it when I need it. And then there's, hey, just reduce the complexity for me, the decision maker. And if you can just give me 3 good choices or 2, I'll pick them based on my experience as an emergency manager. So I think we want to look at, not get obsessed with perfect optimization. If we can take advantage, have perfect optimization and algorithms 5 years ago versus an later from now versus implementations now that don't get it perfect, but let the human make that final tweaking and decision so that they can use it now and get that into their hands for the next big one.
Sorry, one second. Okay, thank you so much again for this excellent talk, Prof. Murphy. Thank you.
Thank you.
Okay, so we're gonna have a little delay for our next speaker. Okay, all is good actually. Okay. So let me introduce you to our next speaker, Professor Dick Den Hertog, who's a